Morning. Glad everybody was able to make the morning session on the last day. All right, my name is Bryson Tyrrell. I'm a systems development engineer on the Java Cloud engineering team. And today I'm going to be discussing Lambda. It's a part of the serverless stack that's available from Amazon Web Services. Who here has actually used Lambda in their environment? Okay, we got a few. So hopefully you pick out something out of this today. Don't worry about this being overly technical. It very much is an introductory session. So we're going to be covering everything that goes around Lambda so that you can start using it on your own. So kind of the agenda I've lined out for this session is to cover what is serverless, because it is a buzzword that's getting thrown around a lot in the past year. And then also cover what is Lambda as a part of that. What AWS services work with Lambda, because Lambda is just a piece of it. It's actually meant to be tied into a whole bunch of other things to provide a solution. Templating your functions. How do we actually deploy these things in a repeatable manner? We're going to spend a bit of time talking about IAM permissions, because it's important and it can be confusing. We'll walk through some example code. Then we're going to cover packaging and deploying these Lambda functions. And then once deployed, how do we troubleshoot things when they aren't quite working the way that we need them to? And then lastly, we'll wrap up with hopefully a healthy amount of Q&A, and hopefully we have plenty of questions after we wrap up. All right, so first off, what is serverless? AWS actually does have a definition for what they consider a service to be a serverless service. The first being that there are no servers to provision, serverless. You're just creating services and you're not worrying about the underlying hardware, the underlying infrastructure. You don't worry about any of that. You just have something that's available and it runs. Scales with usage. Another core concept of serverless is that you don't worry about providing enough resources to make sure that the service is able to scale to demand. It will take care of that for you. You never pay for idle. According to AWS's definition, anything that's in their serverless stack, you only pay for it as it's being used. You don't pay for it when it's just sitting there. And then highly available and highly durable. So who here has an AWS account? All right, so you understand that there's this concept of regions. AWS is broken up into a bunch of regions. Within those regions, they're broken up into availability zones, which it's really not an accurate description, but you can consider those to be data centers. So if you're deploying a service, with a few exceptions, serverless resources exist at a regional level. When they're running, like I said before, you don't worry about the underlying infrastructure that goes into them. They actually run across all availability zones within that region. So in the horror event where an availability zone goes down within a region, if you're running a serverless app, it's going to continue working just fine because it works across all those AZs. More traditional stacks that rely on EC2s, virtual machines, you actually have to deploy virtual machines and manage them in each availability zone and have them clustered or just linked together, so that way if an AZ goes down, your application can continue running. All right, so the most important thing to take away from all of that I just mentioned is really that serverless abstracts the infrastructure away from your code. Whatever you're doing, you no longer care about how it's running, it's just running, which frees you up a lot when it comes to actually just getting things done. So everything I got on the screen right here is actually considered to be a serverless offering from Amazon. And they're all grouped into categories. S3, I'm pretty sure everybody here is familiar with S3. It's probably the most widely used thing in AWS. It's a storage service, and there are actually a few others. DynamoDB is a database service. It's a NoSQL database service. We're going to keep throwing buzzwords out there. API Gateway and CloudFront are considered to be networking services. Step functions, SQS and SNS are integration services. SQS stands for Simple Queue Service. SNS stands for Simple Notification Service. SES, which is their simple email service, you get this theme where Amazon likes to say a lot of things are simple, is technically called Customer Engagement Service. Cognito, which is kind of fun, is an identity service. so that instead of rolling your own identity management system for people to authenticate against, they have something to handle that for you, so you can tie into things like OAuth with social media networks, GitHub accounts, things like that. And then finally, we have Lambda, which is the compute service. Lambda is the one piece that ties everything together with the custom business logic and code that you need in order to achieve your end result. So Lambda is running the code without a server or worrying about provisioning a server to run your code. It also follows the other industry buzz term, functions as a service. And it's actually not an Amazon-specific thing. Google and Microsoft on their cloud platforms also offer their own version of functions as a service. But Lambda is, I believe, the most popular one. So you actually have a lot of freedom when it comes to Lambda because it does support a lot of languages. For those of you who really want to, it does support C# and the .NET Core. And actually, it was just updated for .NET Core 2.1. Go 1x, Java 8, Node 3 flavors of Node.js, and then Python 2.7 and Python 3.6. And I personally do all of my development in Python 3. So a Lambda function is going to be generally one file that you have, and in that file there's going to be a function that's called the handler, and this is what the service is going to invoke whenever the Lambda function itself is invoked. So this is the most basic version of it, where it's just doing the serverless version of Hello World. This is what gets called, and then it gets passed two objects. The first one is going to be the event object. It's actually going to be a Python dictionary that contains all the information that was passed by whatever service invoked Lambda, and then Lambda can use that in order to do its processing. The second one is the context object, and I'm not going to actually explore the context object today, but it contains things about the runtime environment for Lambda. So one thing I will point out is that Lambdas have a finite amount of maximum runtime. The maximum amount of time a Lambda can run is 5 minutes. Inside the context object, if you're doing a long-running process in there, and you want to use up as much of time as possible, or even if you aren't using up the maximum of 5 minutes, there's a timer in here so that you can go call the method on it to check how many milliseconds are actually left in my execution time. So if you're looping over something, you can still gracefully exit out of the function before you actually run into a timeout, and then it just dies. But we're going to be covering the event object a lot more in a little bit here. So I mentioned that Lambda is one piece out of a whole puzzle. So there's a whole bunch of things that are actually meant to work with it. You can manually run Lambda functions, just from the console or by invoking them using the command line tools, but they're really meant to be triggered off events. Serverless is really an event-driven application architecture. So you have options available like triggering a Lambda every time a file appears in S3 or it gets deleted. API Gateway is one of the most popular ways of tying together Lambda and creating a serverless application. You can create a HTTP API that has Lambda on the back end, so every time you make a request to it, you're able to process those requests and go perform actions. Simple notification service, I mentioned that one briefly just a little bit ago. SNS is sort of a fan-out service. So you have what's called an SNS topic, and then you have subscribers. It's a pub-sub service. So it's a way for you to actually trigger many things off of a single event. So when you have SNS, you can do things like just send notifications like texts, emails, basic HTTP posts of the event to somewhere else. But you can also subscribe Lambdas to it. So whenever you send something into SNS, it will trigger every single Lambda function that's subscribed to it. So this is actually a really cool way of building some orchestration around, say, like employee lifecycle actions. Once you drop a message into SNS, if you have a whole bunch of individual things that have to happen all at once off that one event, use something like SNS in order to do a fan out and have them all run concurrently. And then we have CloudWatch. Who's familiar with CloudWatch? So CloudWatch is Amazon's monitoring service for everything that goes on in your account. There's a whole bunch of stuff in there. There's also this concept of being able to create rules, where for certain services, there are a bunch of different events that you can listen for, and then you can have it take an action on those events. Normally, this is used for things like notifications and alarms. So like say an EC2 instance goes down, you have a rule set up which will notify you by email if that happens. You can also have a Lambda function be the triggering what gets triggered when that rule happens. So think about like if you have things like EC2 terminations that might happen, or an EC2 instance goes down, you can have a Lambda attach to that rule, which will automatically, because the information will be inside that event object, attempt to perform some sort of immediate remediation on that instance while you're getting notified about it. So it could attempt to restart it automatically while you're still being notified. And then the other piece is CloudWatch is also where you define schedules. So this is essentially running cron jobs in the cloud. So if you create a Lambda function, you can execute it on a cron-like schedule. So if you have anything that's routine automation that needs to occur, you can actually have this all handled by Lambda. And then just recently, like 2 weeks ago, SQS was added as an event source for Lambda, and this is really, really cool. So before this, SQS is a queue service. It's really simple. You create a queue, you can drop messages in it, and then using the AWS SDK, you can just start pulling messages off of it and process them. The catch here was, with the exception of using, I'm not going to get into it, but with the exception of using Elastic Beanstalk, you had to write your own recurring service in order to pull that queue, to pull messages off, and then go process them. Now, they actually built a direct trigger in, so that way, if you attach a Lambda function to the queue, they have their own poller that they manage on their own. You don't have to worry about it anymore. It's always listening to that queue, doing what's called a long pull process. And as messages appear, it's automatically going to be invoking that Lambda function. So that way, you can start flooding your queue with tasks, and then based upon whatever limits you put on that Lambda function to do the processing, it will start pulling messages off, executing that Lambda up to the limit that you defined. And that way you can actually, you don't have to worry about throughput. You can just throw as many messages onto the queue as you want. They will all eventually get processed at some point. And you don't have to worry about managing your own poller. So let's do a quick walkthrough of creating a Lambda function. Who's been here in the console before? All right, so we're going to explore what I consider to be the wrong way of doing it. So if you need to create a new Lambda from scratch, you got a couple of options. You can do author from scratch, where it's going to be completely empty, or you can select one of AWS's pre-existing blueprints, which they have a whole bunch of styles of Lambdas to achieve certain things with other AWS services, and then you can modify those as you see fit. And then there's the serverless application repository, which is new, and I'm not going to cover that, but that doesn't involve creating Lambdas. It involves actually using other people's Lambdas. All right, so if we're creating one from scratch, the first thing that we need to do is we need to create or associate an IAM role, so that way it has permissions to be able to do certain things, like execute. And we're going to come back to IAM in a second here, but at that point, you have to create or assign an existing role. Then past that, we're going to come to this screen, and we're going to get this nice new editor. Amazon recently purchased a company that did web-based IDEs, and then they integrated that into this console. It's a really, really great editor. So we can use this to write our code, copy and paste. It does auto-formatting and other nice things. But once we got our code in there, then we have to switch over and actually say, well, what's going to trigger our Lambda function? So we need to configure the triggering events. Like for this example here, we want every time something drops into an S3 bucket, we want it to execute this Lambda function to actually process that file. There's actually a lot of clicking in the GUI just to get to this minimum state, and it's not really reproducible. So we just did all this in one region. If you have to do this in another region, or you have to do this in a different account because you separate out test accounts and production accounts, these are all manual steps that you're doing. None of this is reproducible in a really meaningful manner. It's very error prone, especially when it comes to like doing things like IAM. You have two browser windows open and you're looking at what you got on the left-hand side and trying to recreate it on the right-hand side. It's a pain. You don't want to do it that way. So this is where we're going to switch gears and we're going to start talking about CloudFormation and CloudFormation templates. Who's familiar with these? Fantastic. So you're all going to learn something today. So CloudFormation is a JSON and YAML format for defining a AWS infrastructure as code. Who's heard the buzz term infrastructure as code? See, we're hitting all the right ones today. Is anyone playing bingo? You should be. All right. So this is a huge thing with AWS. CloudFormation is really the core thing to it. It's the orchestrator. You define everything inside a template, and then everything that you've defined in that template, you will be able to recreate that exactly every single time you run it. It will also allow you to take that template and run it multiple times in order to just build additional copies of that service if you're changing parameters, because you wrote generically to perform a task, but then based on the parameters, you want it to do different things against different targets. You can just rerun the template to spin up a new one. So when it comes to serverless things, especially Lambda functions, these templates can tend to be very verbose, because when you're browsing around doing things in the console, it's just sort of automatically doing a lot in the background for you. But when you're defining them in the template, you'll find out that what you think was one thing you created is actually 4 things in the back end. So with a Lambda function, it's not just that function that we created in the console. There's also that IAM role, that's its own unique object. There's the permissions for that IAM role, which is actually its own unique object. There's the Lambda function object itself. And then you also generally have to configure the event that's triggering it separately as well. Yeah, so this right here actually represents all those things I just described. I'm not actually defining 4 different objects here, I'm defining 1. And the reason why I'm able to do that is because of this handy little key up here. So, over a year ago, Amazon introduced what they called the serverless application model. And what it actually is, it's an extension to CloudFormation. When you throw this transform key on here, it opens up new models that you can use in your templates, and CloudFormation will know how to work with them. Specifically, serverless models. So, if you're going through the documentation for CloudFormation, you'll see it's always like AWS resource type and then what the resource object is going to be. So like AWS S3 bucket, if you're creating a bucket like I've got up there. So like that's a standard CloudFormation model. I can continue using in this template because all I've done is added the extension to it. For the function, the serverless models all take a whole bunch of the complexity around creating some of these objects, and it simplifies the syntax drastically down and makes it so that you can more easily template those items. When CloudFormation actually processes this template, it's going to take this object and translate it into all the other ones. And really, we just got some basic things here to tell CloudFormation what to do with it. I've got my runtime stated here, Python 3.6. And then I'm telling it where the handler is. So on the first half of that, I'm telling it what the name of the file is. On the second half of that, after the period, I'm telling it what the inner function it's going to execute is. So if you remember back to my very short Hello World example, consider that was one file called Lambda Function, and then I had that one file was going to be the Lambda, and then that inner function that said Lambda Handler, that's the handler. You don't have to name them these things, though. You can name them whatever you want. It's just that when you see in the examples online and in other documentation where it says Lambda Function and Lambda Handler, what it's really saying is file name, function name. And then code URI, this is me telling the template where, relative to the template file, is the code. So the code has to live inside a directory. And then what happens is later on when we go to package this and we're processing the template, the command line tools know where to go in order to get my code and then upload it. So that lambda function.py file is going to be inside that src directory. Should have mentioned that. And then down here, this is where the magic happens. This is the events section. This is where we can say, I want this Lambda function to be triggered off of these events. So in our example here, we're going to be walking through and building something where a Lambda function gets processed every time a file is uploaded to an S3 bucket. So we've got these events. Object create events is actually just a label that I'm giving it, because you can have numerous events all tied to this function. It doesn't have to just be one. I'm only doing one here, and I'm calling it object create events. Type is S3. This is in the documentation, which I will point you to later. And then under the properties, I'm telling it what bucket it's going to be triggered off of, and then what the event is going to be. So you see inside bucket here, I have this little exclamation mark. It says ref, and then just the word bucket. Well, at the top of my template, you can see I'm creating an S3 bucket with this service, and I've just given it the stupid label bucket because that's really descriptive. The ref is actually it's called an intrinsic function. So in CloudFormation, there's actually a whole bunch of little shortcuts that you can do inside templates in order to reference other things inside the template. It doesn't mean anything to the YAML file itself, but when it gets processed by CloudFormation, it knows what to do with those things. So I'm actually linking these two objects together inside this template. So when CloudFormation goes to process it, it's going to know, hey, the bucket that was created in this template, whenever a S3 object create event happens, I'm going to, this Lambda trigger needs to be executed. All right, so at this point though, we still need to grant the Lambda function permissions to go do things with that S3 bucket. So this is where we need to start talking about IAM permissions. And who here likes IAM permissions? Who here has gone into the console, looked at IAM, and then reconsidered the choices that led to that event? IAM is actually not that bad once it's been properly explained, and I'm going to take a stab at properly explaining it. Everything in AWS, acts under the assumption that nothing has permissions to anything. You have to grant permissions. So our Lambda function, even though it's being triggered from S3, in the background, when CloudFormation creates this thing, it's actually going to be granting the S3 service permission to invoke your Lambda function. Everything has to be granted permission to do something. That doesn't mean our Lambda function has permission to go get things out of our S3 bucket. We have to grant it permission to that. This new policies key is how, in line with our function, we can tell it what it's allowed to do. All right, so in your quest to better understand IAM, who has seen examples that look like this? Yep. This is really, really bad and not the right way to do things. So like I said, AWS works off of the least permissive model. You start off with permissions to nothing. You should only grant permissions in order to achieve what you need. Oops, I lost my place in my notes. Yeah, so especially with things like S3, when you're going through it, you might find examples that look a lot like this. And this is really just them trying to get you to the end result of having a working service with the least amount of frustration. But there are many, many problems with this. First thing is this IAM permission is granting access to all S3 actions. S3 star, it's granting all S3 permissions. So that doesn't just mean the ability to write and delete data out of a bucket. It also means the ability to create and delete buckets or modify access to buckets. It's granting whatever gets this will have permission to do all those actions. And then there's this, where resource star. Well, in the first line in the action, this policy is granting you permission to do every S3 action. On this line is granting you the ability to do that on every single S3 bucket and S3 resource in your account. This is an overly permissive permission. Yeah. This breaks the least permissive model. It's not a good idea. Our function, all we want to allow it to do is pull things out of the bucket. That's all we want it to do. So we're going to take that bad example, and then we're going to narrow it down to just what it needs to do. So that what you saw in the template looks a lot this is what it looks like when you're just browsing around in the IAM portion of the console. You can see here that I've now stated the only permission I'm granting as a part of this is S3 get objects. So nothing to do with buckets, nothing to do with access controls on those buckets. It can only read content out of the buckets. Whoop. Oh, yep, I did want that. And I went too far. Go back. All right. If I want to grant more than one permission, then we switch from just having that one key right there to making it a list. So if I wanted to be able to allow this function to get data and write data into a bucket, I would just add, I would make this a list and then just add the next permission down on the line. And then there's the resource itself. I don't want the function to actually have the ability to go into any bucket and be able to do those things. This function is tied directly to one bucket. I only want it to have permission to interact with that one bucket. So we have to be explicit about that, and we have to provide it an ARN, which stands for an Amazon Resource Name. And ARNs are, I think, the other half of the confusing piece of the puzzle, because you look at this thing and you kind of wonder, how do I actually make sense of it? Well, they really aren't that complex because they actually sort of follow like reverse domain name conventions. So first, at the very beginning, it's being stated that it's an ARN for AWS. Then after that is going to be which service which service this resource is going to be in. So that's going to be things like DynamoDB, API Gateway, S3, and so on. And then we're going to have the region. And like I said, the majority of AWS services are all regional based. There are some exceptions where we have resources that are actually global. They don't have any regional scope to them. But for the most part, and actually S3 is like that. I'm going to explore the S3 ARNs in just a second. But for the most part, when you're talking about ARNs, you're going to have a region tag in there right after the service. So we started at the broadest scope, and then we're gradually narrowing the scope about where this thing is located. And then the account ID is going to be your account ID. So we're going from AWS to service to the region, and then what account in that region it belongs to. So this syntax that you see me using here, where there's a $ curly braces, kind of like a bash variable. They're not just there for show. This is actually another one of those shortcut things that you can use inside CloudFormation templates. And these are actually called pseudo parameters, these two right here. Service would be like how you saw me do ref bucket, and I was referring to something. If I had something called service in my template, this is one way I could refer to it inside this string. These are pseudo parameters. They're special environment variables, you could say, for CloudFormation that you can insert into your template in order to fill in the blanks. So instead of having to hard code regions or hard code your account ID, you can use these, and then your template all of a sudden becomes portable, which means not only can you reuse that template across different regions because you haven't hard coded it, you can also use it in different accounts because you're not hard coding the account ID. And then lastly, finally, we're going to say which resource and then which object, and then which resource type and then which resource. So we have AWS, service, region, account ID, and now the resource type and the resource. So for things like DynamoDB, the resource type is going to be a table because it's a database table. And then the resource would be the contents of that table. So it would be table/star. For S3, it would be bucket, the name of the bucket / and then either a star for all the contents of the buckets, or you could be even more specific about that and actually give paths. So if you wanted to restrict permission to only be able to do certain paths within an S3 bucket, you can actually do that. All right, so let's look at a couple of different examples here. So I mentioned DynamoDB a few times here. So here we have one. This is a DynamoDB table in US East 1 with a made-up account ID, and then table / and the name of my database table. I misspoke a moment ago. It's not the contents of the table. It's the name of the table. There's a few different resource types in DynamoDB, but If we're just talking about a database table, you use table / and then the name of it. All right. I mentioned S3 falls under that special global category of things that don't have a region. S3 is a little more special than even that because S3 buckets are globally global, which means when you create a bucket in AWS, because that bucket can be made externally facing, the name you give it becomes its registered DNS name. So anytime you create a bucket, that is the only bucket of that name that can exist in any AWS account in the world. And that's to avoid name collisions. So you'll see right there after S3, we actually don't have anything entered for a region, and we don't have anything entered for an account ID because an S3 bucket, those things don't apply. Once it's created, it doesn't matter the region or the account. It's a global resource. You can only ever have one of them, so those are intentionally left blank. But after that S3 service, and then we have those two blank fields where our region and account ID would be, we then have the name of our bucket. In this particular case, I just have the name of the bucket, which means this ARN is specifically for the bucket resource itself. If I want to do the contents, I then have to have that / and then the pathing out to either the start, the asterisk for all contents, or I could be more specific. All right, so now with the addition of our IAM policy on the Lambda function, this template is now complete. We're going to walk through now what the code actually does. So we're going to do a code walkthrough about what the triggering function, how it's written, and how it's executed. So, and this is a really short one. It's nothing too fancy. So this is that lambda function.py file. So in our template, we said it's inside the src directory, but then what Lambda is going to be invoking is lambda function.lambda handler. So this is the whole lambda function.py file. And then in here we have our lambda handler, and we're going to walk through what happens when S3 triggers it. At the top, I'm doing some imports. You can see that I'm importing a library called Bodo3. Bodo3 is the software development kit for Python. Now, what's going to happen is when a Lambda starts for the first time, it's going to have to go through what's called a cold start. So Lambdas are not just instantly available all the time. Like we mentioned before, you don't pay for idle, but when you don't pay for idle, if they aren't being invoked, they aren't going to be actively loaded. So what happens is the very first time a Lambda gets invoked, it has to go through this cold start process where the file gets loaded into the Lambda service, and then it gets executed. So it has to go through all your import statements, any global variables you define, anything that's outside of the execution scope, so like when that Lambda handler function gets run, anything that's pre-processed outside of that, like imports and so forth, that all has to happen as a part of the cold start process. So there's always a slight delay for when you first start a Lambda function to when it finishes execution, because it has to go through that. On the flip side, though, what happens after that is it's going to remain loaded in the service for a period of time. So after that first cold start, for the next, I don't know what it is, 15 minutes or so, subsequent executions of that Lambda are going to be nearly immediate because it's already been loaded. And then after whatever that timeout period is happens, it'll actually be unloaded from the service automatically, and then it just will wait for the next time you invoke it to go through that cold start process again and have it reloaded. All right, so let's talk about what happens now after that cold start, and now it's actually finally being invoked. So our handler function is going to be executed. We're going to get the event and context objects, and the event object, as I said, is just a Python dictionary every time, so you don't have to do any special handling of it. It's just ready for you to start interacting with. And inside here, you can see that I'm actually going over some data that's inside that event from a key called records. And on each entry from that, I'm going to be reading out this other key for each record that's called S3. And in there is going to be the name of the bucket and the name of the file that got uploaded. But, begs the question, how did I actually know what to look for when I was writing this function? So there are actually documented examples of every single type of triggering event for Lambda in the AWS documentation. This one right here, I copied straight out of the section for S3. This is what I used in order to figure out what it was going to be passing me for event data. Because records is an array, I wrote it as a loop because there's always the chance that multiple file write operations might happen at once, and the event that gets triggered might have multiple files contained inside it. So if you go to the documentation and you're building a service that's event-driven and you need to know what to expect, this takes a lot of the guesswork out of it. All right, back to our code here. Next step is that we're going to be downloading the file that's triggered our Lambda in the first place, and I took that, instead of having it inside the Lambda handler, I split it out into its own function. In my example here, I'm actually expecting, in this service, I'm expecting that every single file that gets dumped to that bucket to be a JSON file. So I'm just, lost my train of thought here. There I am. All right. Yeah, so I'm expecting every single file in here to be a JSON file. I'm not doing any special handling of that. I didn't get into it, but if you remember back to our CloudFormation template on the events section, there's actually an additional option I'm not taking advantage of that's called a filter. So you can actually have the events filtered on file types. So if I want to make different Lambdas to only process certain types of files, each event for that Lambda can have a filter on it to actually narrow that down. I'm just making the assumption that everything I throw into this bucket will be a JSON file right now. So now inside my Git file, I'm using Boto3 in order to call out to AWS and then download that file from the bucket. I got the bucket name and the file name from the event object, so those got passed in here, and then I'm just using Boto3 in order to download it. So who here has played around with interacting with AWS using like Commandline Tools or the SDK? And who has had to mess around with access keys to AWS in order to do that stuff? If you raised your hand the first time, you had to raise your hand the second time. So one thing that you didn't see anywhere in my template or anywhere in here was me providing access keys to this Lambda function. The IAM role that we put in line with our function that granted it permissions takes care of that for us. So in the Lambda service, when this Lambda function starts up, it actually is granted in the environment temporary credentials for whatever AWS resources are defined inside that IAM role. Boto3, their SDK, knows what environment variables to look for to see where its access keys are. So when it starts up, it actually picked up that there's an environment variable with an endpoint for it to go connect to in order to get its temporary credentials, and now they're loaded in memory. So I don't have to do anything special with setting up Boto3 in order for it to be able to make API calls to AWS. That's all being taken care of for me by the SDK in the Lambda environment. I don't have to worry about configuring those credentials. It's just doing it. So one thing that I'm going to say right here is see this file object thing and the io.bytes.io thing. This is just a handy little trick where I don't want to have to do the loop where I'm actually having Boto3 download the file into the disk and then I load it and then I read it from the disk to put it back into memory and then do my work on it. This is a handy shortcut to actually just create a file-like object that's in memory. So when I pass it to Boto3, it thinks it's getting a file to write to, but it's actually just writing everything into memory and I never have to touch the disk. This has the added benefit of making this execution just that much faster. All right, so once that's download complete and I have the JSON file I have all that JSON in memory and it's ready to use now, I can process it. And I don't actually have anything in this example function to actually do that. I don't have any code here showing any parsing, manipulation, anything like that. But I do have this little piece at the bottom here to actually take that data and then post it to some remote HTTP service. You know, maybe something like Splunk. Maybe I was taking in some incoming files, parsing them, and then throwing them at Splunk afterwards. You might notice that I'm using requests here. So request is a third-party Python library for making HTTP requests. It makes it really simple. But something I'm not touching on today is how to actually build and deploy Lambda functions that have third-party packages included. Request is a third-party package. Really handy shortcut, Request is actually embedded in the SDK for Bodo 3. So Bodo 3 uses another package called Bodo Core. Amazon provides this as a part of the Lambda environment, so you don't have to deploy it on your own. And embedded inside Bodo Core is the requests library, with a catch. Bodo Core is, the reason why it's embedded is because they wrote Bodo Core with very specific versions of certain libraries that are dependencies. Request is one of them. This, when you're importing it like this, you're getting an old version of requests. The current version of requests is last time I checked, which was last week, was 2.19. The version that's bundled with Bodo Core is 2.7. Now, functionally, you're not missing out on much, but there might be some features that are present in later versions of requests that you aren't going to get with 2.7. So if you need to check on that, you just need to go look up the documentation for request, the older version requests, and make sure that you're using it the way you're using just the methods that are available for that, because it's going to lack some of the newer functionality. But this is really handy if you need to do some basic HTTP interactions as a part of your function, and you don't want to go through the hassle of bundling a third-party resource with your Lambda. All right. Now we're going to we're going to move forward into actually doing that packaging and deployment of our function. So we have a template, we have our source code, we're actually ready to go at this point. So this is a little overview of what our serverless repository looks like. So, ideally you're using Git, you're using GitHub, GitLab, Bitbucket, whatever. You're using some sort of source control. And then your little serverless application is going to be one repository. And in that repository, we're going to have our template file, and then we have our source code inside that source directory. And actually, if you were doing something with multiple functions, I would say you take this a step further, and you do source functions, and then a directory for each individual function to structure it. And you just do the paths inside the template, to point to the correct locations. All right, so we're going to package and then deploy our serverless application. And the good news is that the AWS Commandline Tools, which some of you might have already been using for things like quick uploads to S3, they can perform both those steps for us. If you don't have the AWS Commandline Tools, they actually are a Python package, so you would install them with pip, and then you'd have them available on the command line. If you don't have pip, a really quick Google search will tell you how to install it on your Mac, and then you can go and install the command line tools. And if you happen to have Python 3, and Python 3 is starting to become recommended, especially as Greg would probably agree, don't touch the system Python if you don't have to. Install another copy of Python, preferably Python 3, and then use that to install the command line tools and any other packages that you might be working with. And it should also be noted, actually, that like in our Lambda, we are using Bodo 3. The AWS Commandline tool uses Bodo 3 as well. All right, so once you have the command line tools from the application directory, so you open up a terminal and you change into the directory where your template file and your source directories are, we can now call AWS CloudFormation Package in order to package up our application. So this command, if you have used the AWS command line tools to do things like interacting with S3, you would know that you do AWS S3 and then whatever that action is, like upload file or whatever. In this case, we're working with CloudFormation. First argument is we're telling it what the name of what the template file is that we're actually going to be referencing to perform the packaging on. And then we're giving it an output template file. So CloudFormation, like I mentioned before, is going to process that template. But when it processes that template, if it has resources it needs to create, all the source code for like those Lambda functions already has to be up in S3. So what's going to happen here is during our package step, when it's going through our template and it's packaging up all those applications, it's going to be uploading them to S3, and then the locations of those artifacts in S3, it's actually going to inject those into the template and then spit out a new one that's ready to go in CloudFormation. So what's going to happen is our source URI key that said the directory to where our code was will become replaced with an S3 address by this process. And then lastly, you do need to give it the name of a bucket in which to upload all those Lambda objects to. This is outside that template. This is like you would create a bucket called My Deployments or something unique because, like we said, all bucket names have to be unique. So you create a bucket that you would use for all your packaging steps and deployment steps. So provide that here. And then here's that result I was talking about. This is what the output file looks like. It doesn't overwrite the original template. That's why you're specifying a different file name for the output. Our deployment template file, the code rewrite, has been replaced with the location of the artifact that it generated and uploaded to S3. So now, when we go to feed this into CloudFormation, it's going to be able to pull that code in order to create the Lambda function objects. All right, we're actually going to step back into the console here for a second because when it comes to deploying with CloudFormation, yes, you can do it with the command line, and it is a lot quicker with the command line, but there are some reasons why you might want to be doing your deployments in the console. So, I'm going to create a stack. Oh, go back. That's a little too quick. There we go. So, we're going to go to the CloudFormation section of the console. We're going to click Create Stack. Whenever you deploy a CloudFormation template, what you're deploying is called a stack. That's just what the name means. All right, then we're going to upload a template file, and we're going to browse to the output template, not the source template, but the one that we generated in that package step. All right, and then we're going to come to this options screen, and you can really just click through this. There is something I want to call out here where you have this IAM role box here. You don't need to change that. If you just move past the step, when CloudFormation starts running, it's actually going to be using the permissions of the user you've logged in as. So, warning, if you're logged in as a user that doesn't have permission to create some of the things that you have to find in your template, it's not going to work because it's trying to do it as you. If you have an IAM role that's been created for CloudFormation to create those services, say that you're working in an environment where you have a team that manages all this stuff, and they actually have a defined role that says you can use this role to deploy things with CloudFormation, and it'll assume those permissions instead of yours. That's one way around this, and that's what that step would be. You can pick the role to actually deploy as, and that'll change the permissions that CloudFormation uses. If you skip this, though, it's just going to use your logged-in permissions in order to perform those actions. All right. Then at the bottom here that we need to check a couple of boxes acknowledging that we are allowing CloudFormation to create other IAM resources on our behalf. So this is happening for two reasons. One, because we have that transform key for those serverless models in our template. The other is because Lambda functions need an IAM role and they need an IAM permission attached to that role. So we are actually telling CloudFormation it's okay for it to create those resources. So if you did something like create an IAM role or IAM permission that granted wide access, it's not CloudFormation's fault, and you're telling you that it's not its fault. All right. Then we have to click this button down here that says Create Change Set. So in a normal CloudFormation template, you don't see this button. But it's here because it actually has to process our template and convert those serverless objects into their native CloudFormation objects and make sure that everything works. And then finally, after the change set action, it's going to list out all the changes it's going to do. So it's going to create these 4 resources, and then we will click Execute to launch the stack. And then you're going to get something that looks a lot like this. Let's see here. Yep, so yeah, this was just from the creation. I wasn't sure if I had a screenshot from when I was updating it. But you're going to see a whole bunch of events happening here. And this is kind of the nice thing about doing it in the console because you can actually watch as it's performing actions. The other nice thing is that if it actually fails at any step for any reason, on the far right-hand side, it will give you the error message. So it'll tell you what step it failed on. It'll give you the error message for that. And it usually is pretty clear about why it failed. So, I mean, there's a whole lot of GUI clicking in order to get to this step. It's actually just one line with the command line tools. But the command line tools don't stream the output for you, and you don't get a lot of that instant feedback about what's going on during the deployment. So If you're building something new, or you just want to watch what's going on because you're having some problems, I actually recommend doing it in the console so you can actually see what's going on. So back at the command line, here's that one step that I was talking about. Instead of CloudFormation Package, we're going to say CloudFormation Deploy. For the template file, we're going to point it to the one that we generated during the package step. We are going to give it a stack name here, whereas in the console, when we click Create Stack, we typed it into a field. And then this is the checkboxes. So this right here is us telling, via the command line, it's okay for CloudFormation to create IAM objects. And this is going to actually perform both of those steps that we did in the GUI. So we actually had to upload the template and create a change set first, look at the change set, and then execute the change set. This actually does both of those things in line for you. So it'll, in the background, after you hit enter on this, it'll create the change set, but then as long as the change set succeeds, it'll then automatically execute it. All right, so another little gotcha. Normally when you're using the AWS Commandline Tools, you're working with whatever your default region is listed in your credentials file. So remember back when I was asking for those of you who've used the Commandline Tools before and you had to mess around with access keys, your access keys are going to be in a file in your user directory called .aws/credentials. And you can have multiple sets of keys in there if you happen to have multiple accounts, but usually there's just going to be one set of keys called default. Sometimes if you use the command line tools to create this file, it'll ask you to pick a default region to work in. So when you're doing things with the command line tools, it'll just assume the default region that you have in your credentials file. If you don't have a default region listed, you're actually going to need to specify it. So you just need to add a key in here, region, and then point to the region that you want to be deploying to. You only have to do this during the deploy step, because in the package step, buckets, oh God, I gotta contradict myself here. When you create a bucket, it's a global resource, but it is still regional. Like it's not a global data store. Like the data store still has to exist in some region. And when you're deploying things with CloudFormation, like serverless applications and Lambdas, the source code that it's pulling from has to be in the same region that you're deploying in CloudFormation. So during the deploy step, the bucket that you provide for uploading all those artifacts, it's going to have a region associated with it. That's the region you have to deploy to. If you need to deploy across multiple regions, you'll have to create multiple deployment buckets and just do the package step multiple times, and then perform the deploy step multiple times. I'm going to get questions about that later. All right, so now we've come full circle, and we've got a service out there, and first question that comes up is, why isn't this working? So we actually have some really handy things in, so it's serverless. We don't have anything to log into and go tail logs or inspect what's on the server or anything. We don't have any of that. We have a whole bunch of windows in the console to actually bounce around and to see what's going on. But we do have logging. So anything inside your Lambda functions that either uses that language's logging module or just prints the standard out, like the print statement in Python, that is going to go into a log file specifically for that Lambda function. One of the pieces of the role that gets created for your Lambda functions is permissions to write to CloudWatch logs. So as your function's executing, it is sending logging data out here. So right here, this is actually for the Lambda function that I just created. When you go to CloudWatch logs, there's going to be an option on the left-hand side that says log groups. And then I just navigated, and inside my filter here, you can see that I put AWS Lambda MacAdmins, because that's the prefix for this. So all Lambda functions will be prefixed with /AWS/Lambda, and then it's going to be the name of the Lambda after that. Inside this log group, I actually have a whole bunch of individual log entries. So that whole startup cold process and then spin down process that I described, every time that happens, it's actually going to create a new log entry in here, because that container for the Lambda comes up, it gets a new log entry inside its log group, but then once it spins down again, it's completed, and then when the next one spins up, it's going to generate a new one. This will also happen every time you redeploy your function, because when you redeploy and update it, it's going to tear down any running containers that are out there after they finish their last execution and then spin up new ones. So inside this stream here, you're going to get this. Now, I didn't have any print statements or anything inside my example S3 Lambda, so I'm not getting any logging here right now. But the stream is going to print out some basic information every single time a Lambda function is invoked. And that's going to be a start statement, an end statement, and a report statement. And the report one is actually going to contain some interesting information here, because you can see here that it shows the total amount of execution time, how long that Lambda actually took. It's going to show how much memory it actually consumed. That provides some nice context, because one thing that might happen is you have a Lambda that runs too long and it actually times out because it's trying to exceed the max allotted time for it. So I mentioned before, you can use print statements, or you can use the loggers for whatever language you're writing your Lambdas in. In here, I'm importing the Python logging module. I am creating a logger for it, which is actually just the root logger. If you go look up AWS's documentation for logging in Lambdas, they do tell you just to use the root logger. So all that really means is if you're new to logging concepts, it just means you don't have to do anything special. With Python, you just create a logger without having to configure it at all, and this is what you will just use in order to write statements out. So then I'm setting the level. Again, don't want to get too far into this, but with logging, you'd have multiple levels of log statements in them. Info, error, warning, critical, and what's the fifth one? I'm missing it. I didn't say error? Yeah. Info, debug. Debug, info, warning, error, and critical. Those are the 5 levels for logging statements. What's nice about the logger is that if you're using it instead of just the print statement, you can call, like we see down here. Inside my Git file, I decided to add some error handling. And then if a problem happens and it throws an error, I'm actually calling logger.error. So in my logs, in big capital letters, it'll say error first, and then the line that I put in there. But then for the info statements, it'll just say info, and then it'll print that out. So that's a good way of filtering your logs. If you've browsed around in like the console for the Mac, you see logging statements like that all the time. This is how you do it in Python. Then there's also one other really handy thing, which you have to enable this. And you have to enable this inside your functions in order to actually get the benefits of it. But AWS has a tracing tool for Lambda functions and other services called Xray. So once you've enabled it in a Lambda function, it allows you to actually see a map of data concerning invocation times, execution times, and latency between different things calling each other. This view right here that you can see actually is showing averages over the given period of time for a number of executions and then the amount of time those executions took. The rings here represent green for OK, yellow for errors, reds for faults, which are pretty much crashes, and then purple if it's being throttled. So in AWS, the AWS APIs do have rate limits on them. So if you're going hog wild with the SDK against one of their services, there's always the possibility that you might exceed the given rate limit for a certain period of time, because they do this bucket trickle method where they might say you can make 1,000 requests a second, but you actually are allowed to burst 500 of those instantly, and then it just gradually refills that. It's not 1,000 per second, and it just refreshes automatically. There's documentation about that, and I don't want to get into it because it's a confusing topic, but throttling is a real thing. When it does happen, it does appear here color-coded. So one thing I can see here is that once my Lambda is being invoked, that's okay. The Lambda service has no problem invoking. But then I'm getting errors when my function is running. But I'm not getting errors when it actually is contacting the S3 service or getting content out of my S3 bucket. So this Xray map is telling me that I'm hitting errors, but I'm hitting errors after it's successfully contacted the bucket. If you click on any one of these little donut rings, you can get even more details about it. So we can see here the spread in terms of execution times. I didn't execute this too many times, so there's not a whole lot of data here. But I can also see the percentages across all those different types of responses. If I click on this, I can then go into the trace details, and then I can see even more data about where that error was occurring, and then the amount of time that it was actually taking to perform those independent actions. So if you want to take advantage of this, you have to do two different things. First, there is a tracing key for serverless functions. You just set this to active. There's active and passive, but you generally are going to want to set it to active. This is going to take care of adding to the role for this function the necessary permissions that will allow it to send data to the Xray service. Then you also have to import some new stuff into your function, and unfortunately, the AWS Xray SDK packages are not just available inside the Lambda environment like Boto3 is. These you actually do have to package and include with the function when it gets uploaded. But once you do that, you can call xrayrecorder.configure, and then you can patch the libraries it supports. So Xray doesn't just automatically send a whole bunch of data out there. It supports specific libraries for patching. Boto3 and requests are both libraries it can patch, and really what that patching does is it puts wrappers around them on the backside. So when you're calling those things, it's recording data for the Xray service, and then it's sending that data out there. So that's how you were able to see in that map my Lambda function when it was connecting out to the S3 service, and then it was connecting to pull data out of the bucket. I had telemetry about that. I could see how long those requests were taking and whether or not they were succeeding. That's because I patched Boto3 here. Other things that it supports is actually, this doesn't apply to Lambda, but if you were deploying a Flask or Django app, a web app out in AWS, Xray supports patching those. It's a middleware is what they call it, and that will actually have those applications submit loads of data to Xray about the requests that are happening inside them. On the documentation, there is an option for, it does list all the supported libraries for patching. All right, so I said I was going to be pointing you to some docs later. If you don't want to squint and try to copy these URLs, if you go to the big one in purple, this is a repository that I have on my GitHub account. All these links are there. The serverless application model is on GitHub. I strongly recommend you go check it out because inside there is the full documentation for those serverless models, all the keys that they support, what those keys do, how to configure them, all the event types that you can use to trigger your Lambda functions. It's all actually inside this repo. I brought up those pseudo parameters, those nice environmental shortcuts so that you can make your templates a lot more modular. That's available out in AWS's documentation. The Lambda event examples, those are very, very handy when you're starting to build these things because you have a full copy of that JSON data that it's going to be providing, and you could just work off of that. And then finally, if you want to get into using Xray in order to track how your applications are performing or your functions in your environment, right at the bottom there is the link to the official Xray documentation. And before we switch over to Q&A here, you're all probably wondering about costs. What is the cost of all this magic? Well, AWS actually has a really, really healthy free tier, especially when it comes to serverless. So with Lambda, if you have a full gig of memory assigned to your Lambda functions, you get 400,000 free seconds of execution time. Now I said if you have a gig of memory assigned to it. The way that you scale the amount of resources available to a Lambda function is actually through a setting on it for memory allocation. There's nothing for network IOP, and there's nothing for CPU, just memory. And they actually scale all those resources in line from 128 megabytes of memory all the way up to a maximum of 3 gigs. Now, at 1 gig, you pretty much have one virtual CPU allocated to your function, and you have a gig of memory. Once you start going above that, in Python, you're going to not really get much more out of performance because Python can only run in one processor at a time, unless we start getting into things like multiprocessing and getting around the global interpreter lock. And I said that to scare you away from asking me about it. But generally also your Lambda function should never be that complex. Lambda functions should be generally very single purpose driven. So if you were to crank that down, like the one that we were deploying, the default that it does is 128 megabytes if you don't specify anything. The actual amount of free execution time you get per month with Lambda is 3.2 million seconds of execution time if you're using the bare minimum of allocated memory and resource allotment. So you can actually get a whole lot of mileage out of Lambda. S3, your first 5 gigs of data that you're storing across any number of buckets in your account is free. 20,000 requests to pull data out of those buckets are free every month. 2,000 requests to put data into those buckets are free every month. And then the actual data transfer in and out of your buckets, you're allowed 15 gigs of transfer free every month. I mentioned SQS before because queues are great. Queues are something you should take advantage of. SQS, you get 1 million requests to the SQS API free every month. So remember, these are all services. You interact with everything through AWS's APIs. So with SQS, when you send a message onto the queue, that's 1 API request. When you perform a poll to pull messages off a queue, that's also 1 API request. It's not always one-to-one, though, because you might dump 10 messages onto the queue, but then you're allowed a maximum of reading 10 messages off the queue in 1 API request. So processing 20 messages can eat up 20 out of your 1 million free requests, or 11 out of your 1 million free requests. But you have to do a lot of traffic before you start breaching that free tier, and then it's exceedingly cheap after that anyway. And then API gateway. If you actually want to set up an API so that way you can make HTTP requests to your backend to have your Lambdas do some processing, for new AWS accounts, you get 1 million requests to any of your API gateways free every month. After that, you lose the free tier, but those 1 million requests cost $3.50. And that's not a batch. You don't pay them $3.50 the moment you go over 1. It's $3.50 divided by 1 million. So you have to start racking that up. And even if you do have an API gateway you're paying for, it's really not going to cost you a lot of money. But if you're curious about any of the other services that I talked about in their free tiers, just Google service free tier, and then you'll actually be taken to the page where it describes it in a lot more detail. And with that, we can now open it up to Q&A. All right, this guy.
So a lot of times when I'm learning something new like this, it helps to, like I love the template and how you went through it. That was really great detail. Is there any way to, if you have done it through the GUI, even because you're wondering what you did wrong in the command line, to reverse it out? And
Not
see that?
easily.
Okay.
So there is this concept of, there's this thing called CloudFormer, which is this really bulky, really slow application that you can launch from AWS using CloudFormation. It spins up an EC2 and then loads a bunch of code into it, and then you go to a web UI and you start clicking through services, checkboxing all the things that you want, and then you say output in CloudFormation. I tried it once and it really wasn't all that helpful.
Yeah, it sounds like it could become a crutch.
Now, API Gateway though, API Gateway is not really, the objects for CloudFormation themselves don't have a whole lot of things that you can configure as far as like how endpoints behave. That's actually all done through Open API docs, Swagger. You actually put one in line or you point in the template to the location of where that Swagger file is. And Amazon has tons of extensions to the Swagger spec that you would actually use to configure your behavior, like attaching a Lambda function to act as a authorizer, for example. If you're not sure how to do that because, you look at the documentation and you're like, well, how do I make this work? Handy shortcut is go ahead and build an API gateway in the console, and then use the GUI options to actually configure all the things that you want it to do. And then after you deploy it, it deploys to what's called a stage. And there's an option to export it at that point. And one of the options is export the Swagger doc with the AWS extensions. So when I'm trying to figure out new things to do in API gateway, I actually will go play around, build a new API gateway specifically just to figure out that one thing. And then I will export the Swagger doc so I can then take out all the specific pieces and then generalize it using like pseudo parameters and stuff and referencing other things in my template. And then I have a working example. I actually did that recently when they announced SQS as a trigger source. I actually did that so I could figure out how to directly integrate API gateway so that when you send something via HTTP request, it dumped it immediately onto an SQS queue, which then was being processed by Lambda afterwards, which meant I had a high throughput web API that I could throw things at, and then it was just going to be eventually processed on the back end by a Lambda.
Sorry, there was one other thing, and then I'll.
All right.
But so if you are getting throttling, and this may be too complicated for the scope, but do you then build two, and is there a way to like queue that into two things, or?
The throttling occurs at an account level.
Oh, okay.
Actually, technically a regional level. So if you have like 50 processes running in parallel, and they're all calling one API, if one of them hits that throttling point, they're all going to hit that throttling point. Nice thing though is that if you're using Boto 3, the SDK knows how to handle exponential backoffs. So what it'll do is if it hits throttling, it's actually going to enter a hold state. Try again in a couple of seconds, then try again a little bit more after that, and it'll do it 3 times before it actually bombs out. So throttling, be aware of it, but also go read the docs because some of those throttling limits are actually pretty high. It's just something to call out. Scott, I guess?
So I was just kind of curious, what's the time frame for the cold spin up and spin down?
Seconds.
Okay.
The spin down you don't notice. The spin down is not something that you're ever aware of, and you don't actually know when it's going to happen. But the cold start itself is a few seconds. Now, if you have, if your Lambda wasn't loaded and you actually have some stuff that calls it 20 or 30 times and it wasn't loaded, it's not going to wait for the first one to finish going through the cold start and then do all the other ones. You're going to have 20 or 30 Lambdas all going through a cold start because it's not loaded yet.
Okay.
There's a design pattern that people follow where they actually will, it's kind of funny, they will have another Lambda running out in their environment on a cron job schedule to actually invoke all those Lambdas periodically to keep them warmed. If you're concerned about performance and you want to minimize the cold start impact, that is actually a design pattern that you hear people talk about. More Lambda questions.
Any cool examples or how you're using this in the real world? A lot of potential, obviously. It's kind of unlimited, so it's kind of hard to even wrap your head around where to start.
Well, I've got plenty of stuff on Jamf that I'm doing for Jamf about this, but anybody who follows my stuff, does this look familiar to anyone? So I'm building a hosted service for patch feeds for the Jamf community, where you can go here, you can register, get an API key, and then once you have your API key, you can then use this to host public definitions. And if anybody wants to use your definitions in Jamf Pro for patch policies or patch reporting, they just need this ID right here, and then in the documentation it tells you how to add that feed into Jamf Pro. This is entirely a serverless application on the back end. There are no EC2s, there's nothing about that. It's using API Gateway, it's using S3, it's using Lambda, it's using DynamoDB. But yeah, so this is an example of something that I've been building for a while. The automation I'm doing, the new version of automation I'm doing for Jamf on the back end for Jamf Cloud is all going to be entirely serverless as well. The Jamf stuff? If you want to come find me after we wrap up here, because we've got 20 seconds, yes, I can show you what that looks like. This is also on my GitHub. If you go find the community patch repo on GitHub and go to the develop branch, you can browse the template and all the code for it. But I think we are actually up. So if you have more questions, come find me outside.